Systems and contact forces. Modeling systems and the forces that act on the system's components. Do you recall the apparatuses at each station that you worked on the other day? Can the apparatuses at each station be thought of as systems? What is a system? If you said yes, the apparatuses were systems, you were right. Just like our body has a respiratory system that consists of several components that work together to help you breathe, a system consists of multiple components that interact together. What are the components of the system that influence its motion in this picture? The components are Vehicle 1, Vehicle 2, a rope, and the ground or the earth. Draw this simple diagram of the system which shows the components next to each other. Each rectangle represents a component in the system. This should be drawn on page 12 in your text under procedure question number 1. Please use a ruler. Compare your diagram with the photo of this vehicle in tow. Recognize that the location of the components in the diagram is similar to their location relative to each other in the real system. In the diagram, the boundary between the ground and the earth is dashed because they're not really two different components of the system. The ground or the mud is actually just the top surface of the earth. Which components interact with each other? Two components interact with each other if they apply a force to each other. That is, if they pull or push each other. So which ones are interacting? Well, Vehicle 1 with the rope, Vehicle 2 with the rope, Vehicle 1 with the ground, and Vehicle 2 with the ground. Copy this table into your textbook on page 12. Procedure question number 2. The shaded squares indicate no interaction is occurring between two different components. A plus sign in the table signifies that the two components interact with each other. A minus means that they do not. The next goal is to determine the contact forces that each object applies to the object that it touches. For this, consider the idea that contact forces always come in pairs. A force that is the result of two objects touching each other will be called a contact force. Can you do a high five so that only one hand pushes but does not feel pushed back? When you give someone a high five, this is an example of forces acting in opposite directions. While there are two forces, each hand generates one force and is subjected to the other force. The reason you feel something when you touch another hand is because when two things touch, they apply a force to one another. This picture shows that the hands are pushing the wall in one direction, but are being pushed by the wall in the opposite direction. While there are two forces, each object, the person and the wall, applies one force and is subjected to the other. Besides the forces shown here, the ladder pushing on the wall and the wall pushing on the ladder, what other forces are acting on the ladder? If you said the ladder is pushing down on the floor and the floor pushing up on the ladder, you are correct. In your book on pages 12 and 13, there are questions 3 through 8. Complete them now and then continue with the slides. Return to the diagram of the stuck vehicle being towed. Add a pair of arrows to each adjoining component to show the pairs of forces that exist in the system. An example is done for you. All contact forces, be they pushes or pulls, come in pairs. If one force is a push, then the other one will be a push as well. If one is a pull, the other will also be a pull. This means that the pairs always act in opposite directions.